ವೆರಿ ಗುಡ್ ಮಾರ್ನಿಂಗ್. ಇವತ್ತು ನಾವೇನು ಮಾಡ್ತಾ ಇದ್ದೀವಪ್ಪ ಅಂದರೆ ದ ಐ ಆ್ಯಂಡ್ ಕಲರ್ಫುಲ್ ವರ್ಲ್ಡ್ ಈ ಚಾಪ್ಟರ್ಗೆ ಸಂಬಂಧಪಟ್ಟಂತಹ ಇಂಪಾರ್ಟೆಂಟ್ ನೋಟ್ಸನ್ನು ಸ್ಟಡಿ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. ಹಾಗಾದರೆ ಫಸ್ಟ್ ಆಫ್ ಆಲ್ ಚಾಪ್ಟರ್ನ ಯಾವುದರಿಂದ ಸ್ಟಾರ್ಟ್ ಮಾಡೋಣಪ್ಪ ಅಂದರೆ ಸ್ಟ್ರಕ್ಚರ್ ಆಫ್ ಐ. ಹೌದಾ? ಹಾಗಾದರೆ ಐಯನ್ನು ಪ್ರೊಟೆಕ್ಟ್ ಮಾಡುವಂತಹ ಏನಪ್ಪ ಅಂದರೆ ಆಕ್ಸೆಸರೀಸ್ ಅಂತ ಬರ್ತಾವೆ. ಹಾಗಾದರೆ ಆಕ್ಸೆಸರೀಸ್ಗಳಲ್ಲಿ ಫಸ್ಟ್ ಒನ್ ಯಾವುದಪ್ಪ ಅಂದರೆ ಐಲಿಟ್. ಓಕೆ, ಇಟ್ ಪ್ರೊಟೆಕ್ಟ್ಸ್ ಐಸ್. ನೆಕ್ಸ್ಟು ನಮ್ಮ ಐ ಕಲರ್ಗೆ ಕಾರಣ ಯಾವುದಪ್ಪ ಅಂದರೆ ಐರಿಸ್. ದೆನ್ ದ ಮಿಡಲ್ ಪಾರ್ಟ್ ಈಸ್ ಪುಪಿಲ್ಲ. ದೆನ್ ವಾಟ್ ಎವರ್ ದ ಐಸ್ bulged part is called cornea. In between the cornea and lens, what liquid is there? That liquid is called aqueous humor. Then behind the lens, another one liquid is there. Okay, it's a transparent liquid. It's a vitreous humor. Aqueous humor and vitreous humors, these are two types of liquids present in our eyes. Okay, semi-liquids these are. And to see the farthest object and nearest object, our lens adjusts its focal length. Our lens adjusts it's a convex lens. Okay, this lens adjusts focal length with the help of a ciliary muscles. Ciliary muscles put a pressure on eye lens, and sometimes they relax put a pressure on eye lens. Whenever they relax, focal length is adjusted, and that whenever the focal length is adjusted, our eye helpful to see a near objects also and farthest object also. Then the protective layer of our eyes, transparent layer, is that's called as a sclera. Okay, and I already told for you, lens, convex lens. Then muscula lutea, it's also called as a fovea. Okay, it is visible place in our eyes. Then whatever the optic nerves passing from eyes, that's called as a blind spot. If the whatever the rays coming from objects, whatever the light rays coming from objects, if they are converging at a point in where in whatever the nerve endings are passing, okay, then we cannot able to see that object. That's why it is called as a blind spot. Then eye is connected to our brain with the help of optic nerve. Our eye is a three-layered organ. Okay, then first layer is sclera, second layer is a choroid, and innermost layer is called retina. Okay, in retina a small dip is there. That dip is called fovea or muscula lutea. Okay, these are the most important parts of our eyes. Then part and function of human eye. The human eye is like a camera. Its lens forms an image on light sensitive screen called the retina. Light enters the eye through a thin membrane called the cornea. Cornea forms the transparent bulge on the front surface of the eyeball. The eyeball is approximately spherical in shape with a diameter of about 2.3 centimeter. Most of the refraction of light rays entering the eye occurs at the outer surface of the cornea. The crystalline lens merely provides the finer adjustment of focal length required to focus objects at different distances on retina. Iris is a dark muscular diaphragm behind the cornea, and it controls the size of the pupil. The pupil regulates and controls the amount of light entering the eye. The eye lens forms an inverted real image of the object on the retina. The eye lens is composed of a fibrous jelly-like structure. Its curvature can be modified to some extent by ciliary muscles. To change the curvature can thus change the focal length of the lens. The retina is a delicate membrane having an enormous number of light sensitive cells. Those are called as cones. And what another structures are there? Those are called as rods. The light sensitive cells get activated upon illuminated and generated electric signals. These signals are sent to brain via optic nerves. The brain intercepts these signals and finally process the information of our perception. Then power of accommodation. The ability of eye lens to adjust focal length is called accommodation. The ability of eye lens to adjust its focal length is called accommodation. The eye lens is composed of fibrous jelly-like material and its curvature can be modified by ciliary muscles, hence the focal length can be changed as per the requirement. When the muscles are relaxed, the lens becomes thin, the radius of curvature, and hence focal length increases. The radius of curvature, what happens? Increases. That's why focal length increases, thus enables us to see the distant objects clearly. When we look the objects closer to the eyes, ciliary muscles contract, decreasing the radius of curvature, hence focal length decreases. It enables us to see near objects clearly. The minimum distance at which objects can be seen most distinctly without strain is called least distance of the distinct vision, LDDV. Least distance of distinct vision, LDDV, for normal eye. LDDV is 25 centimeter. LDDV is 25 centimeter. Then defects of vision and their correction. First of all, myopia, short sightedness. Myopia is known as a nearsightedness. Okay, a person with a myopic eye can see nearby objects clearly but cannot see distant objects distinctly. Such a person may clearly see up to a distance of few meters. In myopic eye, the image of a distant object is formed in front of retina and not on the retina itself. This defect may arise due to excessive curvature, excessive curvature of eye lens. Okay, short focal length of the eye lens, or what, elongation of the eyeball. Elongation of the eyeball. See, this is what normal vision, normal eye. What happens in normal eye? Whatever the rays coming out from the lens, what object, they pass to lens, and where they converges at a what, um, fovea. Okay, on retina a small dip is there, that's called fovea. Whenever the image is formed in fovea, it's clearly visible. But if the curvature of the what eye, center of curvature of the eye, what happened, increased, then the whatever the rays coming from the object, they not what they not converges at point fovea, they converges at in front of a fovea. Then what we cannot able to see the objects very clearly. If a cornea is, the center of curvature of a lens is increased, in that case also, here this case also, and sometime elongation of eyeball. Because of elongation of eyeball, we cannot able to see what for objects. Then how it is corrected? It is corrected by using concave lens, which is concave lens, and whenever the object light rays passes from concave lens, they are converged at a point where on retina, whatever the small dip is there, that's called fovea, on that place, and we can able to see a clear image. We can able to see a clear image. This is shown here, ray diagram also. See, this is a normal eye, this is object. Okay, it's a pin near point, and whenever the light rays passes from lens where they converges at a point called fovea. This is a normal vision, normal eye. Then myopic eye, what happens, whatever the what light rays passes from the object where they converges in front of a fovea on retina. That's why we cannot able to see properly. Okay, it is because of what, problem of a lens, center of curvature of whatever the problem is there, or sometime eyeball elongation. Because of this also, what happen, whatever the light rays coming from object, they are converges at a in front of our fovea. Then that time also we cannot able to see for objects clearly. Then how it is corrected? It is corrected through what? concave lens. Okay, whenever the light rays come from objects and they enter to in our eye lenses, they converges at where at the place of a fovea, then clearly we can able to see the object. Okay, this is the correction. Myopic eye is corrected with the concave lens. Then hypermetropia, long sightedness. Hypermetropia is also known for sightedness, farsightedness. A person with hypermetropia can see distant objects clearly but cannot see nearby objects distinctly. Such a person has to keep reading material much beyond 25 centimeters from the eye for comfortable reading. In hypermetrophic eye, the image of a nearby object is formed behind the retina and not on the retina itself. This defect may arise due to what long focal length of the eye lens or very small size of the eyeball. Hypermetropia can be corrected by using convex lens of a suitable power. Then see, normal eye we already seen what happens. Whatever the light rays coming from object, they passes from lens, convex lens, and where they converges at a point called on retina. One small dip is there. That dip is called as fovea. But in this case, because of a lens problem, because of what lens problem is hmm, focal length of the eye lens defect in where focal length of the eye lens or what eyeball is very smaller one. In both these cases what happens, the whatever the light rays coming from object they pass in our eye lens and where they converges means behind the retina, not in front of the retina, behind the retina, back backside of the retina. See where they are converging. See here what fovea is there, here backside they are converging. That's why whenever they converges at behind the retina, we cannot able to see the object because perfect place where on retina wherever fovea is there, in that place the light rays are converging, then only we can able to see a clearly objects, otherwise not possible. That's why this is a defect. Okay, then how it is corrected? This is corrected by using convex lens, and whatever the rays coming from object we pass to first convex lens to our eyeball. In our eyeball again what one convex lens is there passing in them, and where it converges at a point called in retina. A fovea is there at that point, it converges, and it can be what treated. Okay, see again they given ray diagram in our exam for 2 marks they ask in exam. Okay, then this is a normal eye. Then because of a lens focal length problem, what behind our retina image is forming, that's why it's not also possible. And because of what eyeball, smallest eyeball, in that case also the light rays are converging behind our eyes, that's why it's also not possible. Then how it is corrected? By it is corrected by using a convex lens, that's a given here. Okay, then hypermetrophic eye is corrected with a convex lens. Then presbyopia. The power of accommodation of eye usually decreases with aging. After 40 age or after 50 age, this problem will occur. People cannot see nearby objects comfortably and distinctly without corrective eyeglasses. This defect is what called presbyopia. It arises due to gradual weakening of the ciliary muscles. Second one, diminishing of flexibility of the eye lenses. Sometime a person may suffer from both myopia and hypermetropia. Such people require bifocal lenses which consist of both concave and convex lenses. The upper portion is concave for a distant vision and the lower portion is convex for a near vision. Then see what happens. Presbyopia of the eye. Normal eye, what happens? Whatever the light rays coming from object, they converges at a point called fovea. But in what happens? Where In presbyopia, uh, whatever the rays coming from objects, sometimes they converges at behind the retina, sometimes they converges at in front of retina. To correct both these, we use a bifocal lens. Okay, then what we use here to correct this disease, we use a bifocal lens. Then a refraction of a light through a triangular prism. What do you mean by refraction? When a light passes from one medium to another medium, whatever the path of the light is there, it changes or slightly light bends. That's called as a refraction. Then, whenever we pass light rays in where in prism, okay, it also undergo a refraction and it changes its direction. It changes its direction. So, refraction of light through prism, okay, in different angle they kept here a prism, okay, this is given in our textbook. And whenever we pass a light here from prism, okay, slightly it bends because a rarer medium to denser medium, light passes, the velocity of light decreases, that's why it slightly bends. Again, prism is a denser medium, then light passes to what rarer medium, then the velocity of light increases, that's again it goes a refraction. Again it goes what, a refraction, and the ray diagram they given there. Then refraction, dispersion of white light through a prism, the phenomena of splitting a ray of white light into its constituent colors based on their wavelengths is called as a dispersion, and the band of colors from violet to red, Vibgayar, is called as a spectrum. It's called as a spectrum. Vibgayar, violet, indigo, blue, green, yellow, orange, red. Okay, they are available on screen. Then this phenomenon is called dispersion of white light. Okay, recombination of spectrum of white light. Okay, Newton done this experiment. First of all, a composite white light he passed to prism. He got seven colors. Those seven colors again passed into a inverted prism. Okay, a inverted prism. Then again he got a what, white light. Based on this concept, he prepared what, our whatever the sources of light are there. It may be candle, or it may be bulb, or it may be sun, or it may be stars. Whatever the sources of light are there, those are all produce composite light. That composite light contains the seven colors. That contains the seven colors. With the help of this only, he prepared a Newton ring. Okay, by taking these what spectrum seven colors, and he what rotates at a very high speed. Whenever he rotates that Newton ring at a high speed, which color we observe there, seven colors we used in Newton ring, but we observe a white color because of this only. That's why what composite light contains the seven colors. With the help of that composite light, what we can able to split seven colors by using a prism. And again those whatever the based on their wavelength, whatever we splitted the composite light, again passing to inverted prism, we can able to get a composite light also. Okay, what we passed, that we got here. Then rainbow. A rainbow is a natural spectrum which is caused by dispersion of sunlight by tiny water droplets present in the atmosphere after a rain shower. The water droplet acts as a small prism. The incident sunlight with a suitable angle of incidence is refracted, dispersed, internally reflected, and finally refracted out by raindrops. Due to the dispersion, internal reflection, different colors reach to the our eye of the observer. The rainbow is always formed in the direction opposite to the sun. Opposite to sun. For example, here is sun. Okay, here is rainbow. How it formed? The rays from the sun travels like this. Okay, this is a, for example, raindrop. Okay, then first of all, a refraction. Refraction of total internal reflection. Okay, internal reflection, total internal. Afterwards, what seven color splits? Whatever the seven color splits, those are visible to human beings. Okay, like this. Three important what three important process phases will occur in where rainbow formation. First one, refraction, whenever the light travels in a raindrop. Second one, total internal reflection. Total internal reflection condition, you know what, whenever the light passes from denser to medium to rarer medium, this is the first condition. And whenever it travels more than critical angle, then only total internal reflection possible. Then both these cases occurs in where raindrop. Then after, whenever the light rays are coming out of the water drop, that water drop acts as a what, prism. That's why seven color splits, and the whatever the seven color splits, what those visible to the observer. Then all seven colors will be visible, no, why? Because the colors are overlapped. Because what some colors wavelength is very short, that's only three colors are visible to the observer. Then formation of rainbow they given. Okay, formation of a rainbow, this is a sunlight, then this is a raindrop. Okay, then what I said for you, refraction, total internal reflection, then whatever the rays coming out to observe, here observe is there, he looking. Okay, this line is parallel to sunlight. Okay, then at this angle 41 degree to 43 degree, the rainbow is we can able to see. Okay, whatever the rays are coming out, those are what, colored rays. Then see rainbow, how it's look. Okay, very nice picture. Nowadays we not seen a rainbow because proper rain is not there. Atmospheric refraction. Refraction of light by Earth's atmosphere is called atmospheric refraction. Flickering of objects above a fire. Flickering of objects above fire. The apparent random wavering of or flickering of objects can be seen through a turbulent stream of hot air rising above fire. The air just above the fire becomes hotter than the further up. The hotter air is lighter than the cooler air above it and has a refractive index slightly less than that of the cooler air. Since the physical conditions of the refracting medium air are not stationary, their apparent position of the object as seen through the hot air and fluctuates. This wavering is therefore due to an effect of atmospheric refraction on a small scale in the local environment. Then, twinkling of stars. The twinkling of star is due to atmospheric refraction of starlight. The atmospheric refraction occurs in medium of gradually changing refractive index. Since the atmosphere bends starlight towards the normal, the apparent position of a star is slightly different from its actual position. The star appears slightly higher above than its actual position when viewed near the horizon. This apparent position is not stationary but keeps on changing slightly since the physical condition of the Earth's atmosphere are not stationary. Since the stars are very distant, they approximate point-sized source of light. As the path of a rays of light coming from the star goes on varying slightly, the apparent position of the star fluctuates and the amount of light entering the eye flickers. The stars sometimes appear brighter and sometimes some at the same other time fainter, which gives a twinkling effect. See, we are here, where we are here. Okay, these are the layers of earth. Here star is there. But where it looks here. Why this is? Because of a refraction, I told for you. Whenever our vision passes from denser medium to rarer medium or rarer medium to denser medium, there is a what apparent change in the position of the object. For example, whenever I explained Kannada medium light chapter, that time I told for you, when you cannot able to shoot with the help of gun whatever the fish is present in water pond. Why? Because whatever we are seeing the fish in place, that place fish is not present. Why? Because light passing, our vision is passing from rarer medium to denser medium. It is what uh, higher than the position wherever the fish is there, or what lower than the position of fish is there. That's why we cannot able to shoot that fish with the help of gun, or we cannot able to what with by using a bow and arrow. We cannot able to in a what Mahabharata, Arjuna hit the what fish's eye. Fish's eye in where it is fish it is in water. Fish it is in where water. Okay, whenever the person having a knowledge of lights, what refraction, then only it's possible. It's not what we call Ekalavya, how he got the education without guru, like that. It's a one type of education. Okay, now in nowadays culture also, we cannot able to study that thing. Now also it's not possible, because how light passes from radar medium to we cannot able to understand. Why? Because how much water is there, okay, how much rare medium is there, how much denser medium is there, we don't know the quantity. Okay, whenever these all things are possible, then only that will be this possible. Okay, that's why. But the twinkling of stars, whatever the star is there, it is what looks for us in this position, but actual position of star is here. Why? Because of refraction. Then what point is whatever the stars light, stars are farthest objects. They are what highly distant to us in light years. Light year, one light year is equal to light travels throughout year. Then whatever the distance will occur, that's called as a light year. Whatever today we are seeing the light from stars, that light is not produced today, that light is produced lakhs to years gap what before. Know these things. Today whatever we see the light from a star, that light is not created today, that created several years back. Okay, keep in mind these things. And what how they looks, they are looks like a point. Then whatever the light coming from those stars, okay, as a point, okay, whenever they passes different layers of earth, then what happens, slightly they move. And whenever they are slightly refracted, they move. Okay, whenever they are passing in our eyes, star looks like a bright. Whenever the light is not passing in your eye, then star looks like a dim. Okay, this is the main reason why planets do not twinkle. The planets are much closer to the earth and are thus seen as extended sources, since it is the collection of large number of point-sized sources of light. The total variation in the amount of light entering into the eye from all the individual sources will average out to zero, thereby nullifying the twinkling effect. Okay, then later we have to discuss that advanced sunrise and delayed sunlight. But for example, what this is our Earth, this is our planets. Planets are what nearest objects. Stars are what farthest objects. Whatever the from point light rays are coming, I told for you. Then stars, if one point is losing light from another point, what light reaches to your eyes. That's why they are not twinkling. That's why they are not twinkling. Then advanced sunrise and delayed sunset. Okay, this is because of refraction only. This is the horizon. Okay, if the sun is below the horizon, then whatever the light rays what coming from sun, where they passes earth's atmosphere, they refract, and where they reach to you. You are here, they reach to here. Then because of refraction, sun is not raised. He not came above the horizon, but whatever the light rays coming from sun, they are reaching to us. They are reaching to us means sun is visible to us. Sun is visible to us. That's why it is called advanced sunrise. And sunset also. Okay, what happens in sunset case? Okay, sun gone below the horizon, but because of a refraction, the light rays passing to our eyes. Whenever the light rays passing from what passing to our eyes from the source of the sun, then sun is visible. This is called delayed sunset. The sun is visible to us about 2 minutes before actual sunrise and 2 minutes after the actual sunset because of atmospheric refraction. See the apparent position of the sun they given here. Real position is here, but sun where he looks above. Okay, and at the time of a sunset also. Okay, real position is here, but where he appears here. Why? Because of a refraction. See, the sun rays are passing and refracted. The sun rays are passing, refracted. To where? Here observe. Then scattering of light. The Earth's atmosphere is a heterogeneous mixture of minute particles. These particles include smoke, tiny droplets, suspended particles of dust, and molecules of air. When a beam of light strikes such a fine particles, the path of the beam becomes visible. The light reaches us after being reflected diffusely by these particles. The phenomenon of scattering of light by the colloidal particles gives rise to Tyndall effect. The phenomenon of scattering of light by the colloidal particles gives rise to Tyndall effect. Tyndall effect can be seen when a fine beam of a sunlight enters to a smoke-filled room through a small hole. Okay, uh, in this scattering of light makes a particles visible. ನೋಡಿ ಹಳ್ಳಿ ಮನೆಯಲ್ಲಿ ಒಂದು ಸಣ್ಣ ಸಣ್ಣ ಹೆಂಚಿನ ಸಂದಿಯಿಂದ ಒಂದು ಬೆಳಕು ಇಣುಕ್ತಾ ಇದೆ. ಆ ಬೆಳಕಿನಲ್ಲಿ ನೀವು ಹೊಗೆಯನ್ನ ಡಸ್ಟ್ ಪಾರ್ಟಿಕಲ್ಸ್ನ ತುಂಬ ಕ್ಲಿಯರ್ ಆಗಿ ವಿಸಿಬಲ್ ಮಾಡ್ಬೋದು. ಯಾಕಪ್ಪ ಅಂದರೆ ಬಿಕಾಸ್ ಆಫ್ dispersion of light or because of Tyndall effect. It can also be seen when a sunlight passes through a canopy of a dense forest. In these tiny water droplets in the mist scatter light. ನೋಡ್ರಿ ದಟ್ಟವಾದ ಕಾಡಿದೆ, ಅದು ದಟ್ಟವಾದ ಕಾಡಿನಲ್ಲಿ ಒಂದು ಸಣ್ಣ ಕಿಂಡಿಯಿಂದ ಬೆಳಕು ಬರ್ತಾ ಇದೆ. ಅದನ್ನು ಕೆನಾಪಿ ಅಂತ ಕರಿತೀವಿ. ಅಲ್ಲೂ ಕೂಡ ನಾವೇನು ಮಾಡ್ಬೋದು ಅಂದರೆ ಟಿಂಡಾಲ್ ಇಫೆಕ್ಟನ್ನು ಅಬ್ಸರ್ವ್ ಮಾಡ್ಬೋದು. The color of scattered light depends on the size of the scattering particles. Very fine particles scatter mainly blue light, while particles of large size scatter light of longer wavelengths. If the size of the scattering particle is larger enough, then the scatter light may be even appear white. Then scattering of light, the experiment they given. Okay, then light with a what small dot they passing a light to where convex lens passes what parallel beam of a light to principal axis, and those light are passed into sodium thiosulfate solution. Then again we kept here lens 1, here lens 2 is there, and here we kept a screen. Okay, then whenever we are doing this experiment, what we visible whenever we visible the light from sides of the beaker, it looks blue color, but whenever we see the light here on screen, it looks a red. Why this dispersion is different in different things? Because of okay, the wavelength of a light decreases means it turns into red. The wavelength of light is short, then it disperses a blue color, first thing. And the particles, okay, smaller particles displacing the light means blue color they disperse. Then denser particles, after some time, what the sodium thiosulfate coagulates, then denser particles they disperse means they disperse a red light. Okay, where it appears here, and blue light appears here. Okay, with the help of doing experiment we can able to understand. True solution, no scattering of light. Colloidal solution, scattering of light. Then a scattering of light by tiny water droplets in the mist. How it looks, see here. Scattering of light by smoke and colloidal particles where in uh, our sky. Scatter of light, blue color of the sky and reddish appearance of the sun at sunrise and sunset because of a scattering of light. Scattering of light. See, I told for you, whenever sun is on our head, then the whatever the rays coming from sun, they are near to us. Near to us means change in the wavelength, and whatever the small particles are there in our environment. Those particles are very tiny particles and they are smaller than light particles. That's why scattered light is blue. That's why sky and oceans appears blue in color. And whatever the for example, whenever the sunrise or sunset, light coming from distant object, and it is passing from what bigger particles in the environment. Whenever it is passing the bigger particles in environment, then the wavelength is changed. Then wavelength is changed means which color it disperses. It colors a red color. It disperses a red color. That's why sunrise and sunset, sun also appears red and the sky also appears red. But whenever a sun is at hot condition, whenever he is at on our head, he is near to us, that time the sky looks a blue color, because of this reason only. The molecules of the atmosphere and the other particles that are smaller than longest wavelength of visible light are more effective in scattering of light of a shorter wavelengths than the light of longer wavelengths. The amount of scattering is inversely proportional to the fourth power of wavelength. It's called as a Raleigh's effect. The amount of scattering is inversely proportional to the fourth power of the wavelength. It's Raleigh's effect. Light from the sun near to the horizon passes through thicker layer of air at a greater distance in the Earth's atmosphere than the light received when the sun is overhead. The correspondingly greater scattering of short wavelengths accounts for a reddish appearance of the sun at a rising and setting. When looking at the sky in a direction away from the sun, we receive scattered sunlight in which shorter wavelengths predominate, giving the sky its characteristic bluish color. Okay, then up to now we discussed the eye and colorful world. Hopefully, this video is useful for you. Okay, how I explain in Canada uh, 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 with my uh, intimate things, that is not possible in English because of a language problem. I don't know, but wherever possible, I tried to give you something. Okay, hopefully this is only audio notes. I told for you several times to make a revision. This notes is helpful for you. Okay, if you feel this is useful, share to your friends and other members. Thank you so much.